heard Malky's mentor this past year. And I think we may have had a shortened session, but still Malky managed to achieve a whole lot in that short period of time. And starting out with very little programming knowledge, she proceeded to learn about Python and then move on to learning all about machine learning and ultimately building a model that will make predictions, which you'll see about shortly. And I think just to point out, one of my favorite things working with Malky was when we kind of struggled with a difficult concept, and I would try to explain it to her, and there would be like a lot of back and forth questions, and then she'd be like, you know what, why don't you explain it to me like I'm 5? And that kind of just like, it forced me first to like try to distill something into the core concepts, but also it demonstrated to me that Malky won't kind of settle and she'll want to understand something, you know, down to the basics, which I think is a skill that will serve her well in solving any type of problems, whether that's in programming or otherwise. So with that, I want to welcome Malky.
Okay, next.
Can the mentees please introduce themselves? I know it's written there, but we are recording this and we'll be publishing it. So if you can say your name and your grade.
My name is Malky M. I'm a 9th grader at SKA, and I have interest in the STEM field. So my mentor is Leah Einhorn, and she works at Kepler Group. She's a software engineer. She lives in New York, and her hobbies include reading and running. Next. So my project's name is Sales AI, and it's basically a project that uses machine learning to analyze item features and sales data to predict future sales. And I chose it because I want to learn more about data science, specifically predictive analytics. And I'm interested in marketing, and targeted ads commonly use similar programs. Next. While doing this project, I learned a lot of different topics and technologies I didn't know about before. So I learned a lot about machine learning, such as supervised and unsupervised learning, dependent and independent variables, and using machine learning libraries. I learned how to understand and analyze data using Kaggle data sets. I learned Python through Code Academy, including data structures and data types. And I learned how to use Google Colab. Next. Okay, so some of my highlights on this program were being able to learn Python and like utilizing it, and knowing I can utilize it in the future if I want to. I'm able to learn about a topic that I find interesting, and I enjoyed watching my algorithm come together, using it to predict the final sales. I'm also learning the same topics in math right now, so it's fun to see the overlap with machine learning and get a better understanding. At first, it was hard to find a data set for commercial data, and I had to be okay with switching the directions of my project. And it gets really frustrating when you're coding and like there's like a tiny little error in your code that's hard to spot, and it got really frustrating. And yeah, next. I learned a lot, and some important things I learned is that I should take the easy route instead of making things harder for myself. Needing help isn't bad, and I learned how to utilize my resources to get the help that I needed. And I learned how to actually understand the code and what I was typing instead of just copy and pasting the code with no idea what it was doing. Okay, next. Okay. First, I have to get the programs that make coding the algorithm much easier. It's like putting many programs into this one to make them accessible and usable. The libraries are tools that I use to program my algorithm. This is letting Google Colab access my drive because that's where my training data set is. This is putting the actual set of data into the program. I put it under the variable df, which stands for data frame, to make the data set easier to reference throughout my code. It contains data like item weight, item type, item visibility, and item fat content. Then I had to clean up the data. There were blank spaces throughout the data set, and I had to fill them in. These lines of code are finding the blank spaces and replacing them with numbers. For blank spaces and columns with numbers like item weight, I use the average to fill them in, while in columns with words like item type, I use the mode to fill them in. I use the average for numerical data and the mode for categorical data to make sure the repairs wouldn't mess up the overall average. This is another step in cleaning up the data. Humans would know that these words mean the same thing, but computers don't. I coded it so that if multiple variables mean the same thing, they'd get classified under one label. I took all of the columns that have words like item type and gave them numbers for each object so the program could read it. It assigns a number to the different entries in the variables and uses them to encode the words. For example, 1 could mean low fat while 2 means regular. This is a visual of the numbered variables. I had to separate the final sales from the other variables. To do this, I dropped the final sales column and saved it under the variable Y, and I took the rest of the data and saved it under the variable X. I fit both variables into linear regression. This means that the algorithm is calculating the relationship between the independent variables like item features and the dependent variables, the final sales. It's finding how the item descriptors and sales are related. It's also known as training the model. Now that I have my training model, I can make it predict and check how close the predictions were to the real sales data. I fed it item data and had it make predictions because the model is now only being given the independent variables, the product statistics without the final sales. This is me importing the data set that I'm going to use to test the algorithm. And this is what I did before with the training data. I'm just filling in the blank spaces and assigning numbers to the variables with words. This is the actual prediction. I took the test data set and ran it through the algorithm that I made with the training data. It's taking the connections it made between the item statistics and the final sales and using those connections to predict the item sales. I assigned the predictions a variable to make it accessible and turn it into a data frame so I could get the visual representation of the predictions. And then this is the print of the final predictions that were made using my algorithm. It shows the estimated final sales. And then that's it. Next. So I got far enough where I was able to make final predictions with the data set. And in the future, I would train it to further improve the accuracy. And I would display the final results using charts and graphs for more visual representation. Next. Thank you.
Thank you so much, Malky. Are there any questions?
I have a question.
Wonderful. Go right ahead.
So, first of all, let me just say that was a really impressive project. I really enjoyed hearing about it.
Thank you.
At the beginning, you said that you couldn't use the initial commercial data you wanted to use because it wasn't readily available. So I wanted to know, how did you find the data that you did end up using?
Okay, so at first I wanted to do a project more based on like consumer statistics. So like, oh, like if the consumer is like a boy or a girl, like sort of like that. And I realized like that isn't a very easy thing to find. So through like a lot of searching, like we decided that item statistics would be a lot more easily accessible, and we were able to find it through using Kaggle.
Wonderful. Thank you so much, Malky. Are there any other? Oh, go for it, Ira.
Hi, I have a question. Actually, first of all, really nice work and very nicely explained. I really like the way you explained something like training and testing and how you're cleaning up the data. Very nicely done. I know that you're just learning this and you did the training and then you did the prediction. What kind of numbers did you get for the prediction? What was the accuracy or precision rate?
Okay, so it's measured using like correlation coefficients because it's sort of like a graph. So our correlation coefficient was 0.51, which is like considered like decent. So like it's like okay, and in the future I would like train it further to improve the accuracy.
Yeah, I mean, yeah, this is your first time. You ran it the first time. That's pretty good. And it's great that you want to actually work further and improve it. So very impressive.
Thank you.
Wonderful. Any other questions for Malky?